This is a P3 reef play for lesson 6, and it is covering the Diels-Alder cycloaddition. So in this problem, the student was asked to draw the diene and dienophile that could be used to make the compound shown. And you'll notice that he's starting off drawing a 6-membered ring. Notice that he didn't elect to copy and paste the starting material, which is okay. Sometimes it's better to draw a structure from scratch if you feel like you really need to know sort of everything about it, or you want to be really comfortable with the structure and really careful. But it can also save you time to copy and paste, and in this case he takes quite a bit of time to analyze two possibilities that he could have analyzed by just copying and pasting the structure, I think, 2 times, and sort of breaking and reforming bonds on those pasted structures. But in any case, at this point, he's dissected the left half of the molecule down into a diene, and what he comes to recognize is that that would leave the CCl2 bridge as sort of a lone fragment on its own. So this is not going to be a viable possibility, and he eventually recognizes this and transitions into a 5-membered ring alternative. He very nicely rotates it so it sort of looks like the 5-membered ring would look like as it was approaching the dienophile, and just goes right in and starts adding double bonds and chlorines to try to extract out the structure of this potential 5-membered ring alternative. And I like that he left up the diene as a point of comparison. So we'll see there he's drawing in the CCl2 bridge, and hopefully now he sees there he's dissected it into the diene, and he's now erasing the 6-membered ring as he's pretty comfortable with that 5-membered ring. Of course, the next step here is to draw in the dienophile. He recognizes almost right away that that dienophile must be a 6-membered ring, so one of the 6-membered rings in the product came from the Diels-Alder reaction. The other one must have been present in the substrate already, and he's recognized that. He's drawn in 2 double bonds. Notice that one of the double bonds is serving as the dienophile. The other one remains in the product, and so is just a spectator throughout the process. And now to finish things off, all he needs to do is draw that last carbon-carbon bridge, that 1 carbon bridge, I should say, across the 6-membered ring. And he does this, and then he adds wedges. And notice, interestingly, again, he didn't elect to copy and paste. So to copy and paste the product and, again, add sigma bonds and pi bonds to make the starting materials would have probably sped up this problem quite a bit, but at the same time, I think he gained a very thorough understanding of what was going on in these 2 reactants by building them himself. So to the extent that he wasn't in a time crunch, this was a great approach to this problem, and you can see that his answer to this problem was indeed correct.